All right, boys and girls, welcome back to the drive through. Carson, thanks for asking this question. I want to fight myself for assigning it to you, but now that I've assigned it, I guess I'm required to give you help on it. This question is hard. And so, if I learned anything in life from Mr. Lothrop or Mr. Imhoff, it's when in doubt, make a picture of it. So let's just try to get an idea of what's going on. We have this function we're not used to. So let's write it as y equals the square root of 4x, which is 2 radical x. And let me just, rather than graph that in my graphing calculator and change all my windows and get all frustrated, let me just give you a rough sketch of what that looks like, okay? In the first quadrant, which is what we're going to be concerned with, and that is the only place this graph exists, it looks like that. And then this is the point 1, 2, right here. And so what they're saying is that there are two circles of radius 6 tangent to the graph at that point. So one of them might look like that, and the other one, that was terrible. The other one might look something like that, okay? And we want to find the equations of those circles. Let's keep in mind that the equation of a circle is x minus h squared plus y minus k squared. Here's my window change thing, equals r squared, where the center is h comma k. And we're going to have two different centers. Okay, h1 k1 will be here, h2 k2 will be here. And we know that our r is 6, so this is going to end up being 36. So now the problem may not seem so intimidating, although it is to me. So how are we going to find the derivative of y squared equals 4x? Why do we need the derivative? We need the derivative so we can find the tangent line. And then I'll tell you why we need the tangent line later, but it goes back to some good old geometry. So let's take the derivative of both sides with respect to x. So you got 2y times dy dx equals 4. So dy dx is 4 over 2y. 4 over 2y. So that's 2 over y, right? Yep, 2 over y. Okay, let me pause real quick. Just check to see how I'm doing. All right, so far so good. I got it right. So now what do we want? Well, we want basically the slope of that line, okay, at 1 comma 2. Okay, so what are we going to do to find the slope? Well, we take 2, which is our y, and we put it in. Come on now. Okay, and 2 divided by 2 is 1. So the slope of that green line is 1, which means the slope of this line right here is negative 1. Okay. All right. So, I mean, honestly, at this point, I'm going to stop doing algebra, I think. Like, I know I got to go right something and down something, and that the hypotenuse is going to be 6, right? So I can do this with like a 45, 45, 90 triangle. If this is 6, then this is 6 divided by radical 2, and this is 6 divided by radical 2. So if I multiply each side by radical 2 over 2, you get 3 radical 2 for this one, and 3 radical 2 for that one. So what that means is that what I need to do is add 3 radical 2 and go down 3 radical 2 from this point. So this point right here is 1 plus 3 radical 2 and 2 minus 3 radical 2. 2 minus 3 radical 2. Okay, and this one right here must be, let's see, 1 minus 3 radical 2, comma, 2 plus 3 radical 2. And then that is what you get for the solution. So, man, tough problem. I hope this helps. Long live Widmapoy. Big ups to Mr. Imhoff and Mr. Lothrop. And being able to end the video. Stalling. Boom!